Parallel? Perpendicular? Well, what's the third option? Neither. And let's talk about how we can check this, like real easily. Like real easily. Just check to see if those two planes are parallel. Not nearly as much algebra as we just did in the last step. I mean, quickly identify this. I'll start with perpendicular. What do you think? Where are the normal vectors hidden in these planes? The coefficients. What's the normal vector of this plane? 1, 4, -3. What's the normal vector of this plane? -3, 6, 7. What would have to happen for those two planes to be perpendicular? You dot them, what would you get?
0.
Does everyone agree? So that's how we can check to see whether or not the planes are perpendicular. Take 1, 4, -3 as a vector. The -3, 6, 7 is a vector. Dot them, he says, if it comes out to be 0, those two planes are perpendicular. Right? You got this going on, or like this wall hitting this wall, the floor. Floor perpendicular to that wall, right? Aren't those two planes? Excellent. So we'll check that. But what if that's not true? How do you know if they're parallel?
They have the same components.
Yes! The corresponding components, all those ratios would be equal. So there's no way these are parallel. Look. Is 1/3 equal to 4/6
No.
equal? No. Yeah, I keep right the next one. This would have to hold true, and those ratios are not equal. By the way, you never care about that last number. That doesn't have to hold. These are not parallel, but that's what we do. I just say ratios, equivalent ratios, right? Are they perpendicular?
Calculate. They didn't calculate.
They are? And when she's saying yes, they are actually perpendicular. 1 times -3. 4 times 6, -3 times 7 is equal to what? These two planes are perpendicular. These two planes are perpendicular. If this didn't hold true and that didn't hold true, I would just say what? Neither. Either. I have a problem like that in a practice set. It's number 25. Can we do something similar with lines? Right? Can we do something similar with lines? Let me come up with a couple. X equals Y equals Z equals 125 plus 4t, 5t, 6t. So I'm just making these up. Here's another line. X equals 17, Y equals 0, Z equals -2, plus 8t, plus 10t, plus 12t. Is there something we can approach similar with lines? Yes. So how do you know if the two lines are parallel? Right? Look at the vectors in front of these t's, right? The parallel vectors. Those would have to be, okay, scalar multiples of each other, which we mean is they'd all have to be in constant ratios, true? How would you know whether the lines are perpendicular? The dot product of that vector and that vector would have to be what?
0.
0, right? Well, that is not 0 because how could you have all positives dotted turn out to be 0? So they're not perpendicular, but are they parallel?
Yes.
Yes. 4/8 is equal to 5/10 is equal to 6/12. These two lines are parallel to each other. Cool. And if neither of those hold true, it's neither. Cool. Hey, great. Hey, so you ready for 12.6? This stuff's really cool, everyone. We're now in section 12.6. We're talking about these quadric surfaces and cylinders. So we'll start with cylinders. You already know about planes, right? All right. Cylinders. This is 12.6. I'll take all this out. Let's start with cylinders. Oh, this stuff. This is interesting. This is an important section because throughout the whole course, Calc 3, lots of fun, but we're going to be seeing these surfaces all the time. And you're going to want to be able to just make a rough sketch. It does not have to be a perfect sketch, but just a rough sketch of stuff. So we're going to start with cylinders. The secret with cylinders, you know, they might have x squares in there and y squares and stuff. And here's an example. Z equals x squared plus 2. That's an equation of a cylinder. The secret is, how many variables are in this equation? That's what I want you to see. So for cylinders, you'll only see how many variables? Only 2 variables. Now I want to be careful, I can't say that's the definition, so I'm not reading a definition from the book, because didn't we just come up with an equation of a plane that had only 2 variables in it? But I'm talking about if you see 2 variables and it's got like x squared in there, or z squared and a y squared and stuff, then you're talking about some kind of what? Some kind of cylinder. Alright? It can even have a trig function. It can even have a trig function in there, but if there's only 2 variables, and it's not the plane, like we had before, where x and y, you just have 5x plus 2z equals 10. Then you're talking about a cylinder. So, what kind of cylinders are we talking about? They can be circular cylinders, or they can be parabolic cylinders. But the key with cylinders, you'll recognize them because they only have how many variables? 2. So I'm gonna hide this. And look at that relationship. Isn't that like a parabola? It's a parabola, but then it's shifted up what?
2 places.
2 notches. Which letter's missing? So what's that mean about y? It doesn't mean it's 0. Y takes on any value, everything. It's like y takes on everything in this relationship. So what we'll do is when we draw this, just a rough sketch, I'll go like this. And when this is the x-axis, y-axis, z-axis. Z equals x squared plus 2. So think of y equals x squared plus 2. What did you do when it was y and x? You went up 2 notches on what? Y and you went like this? So can you deal with me with the z-axis? Can you go up 2 notches? Right? But it's on which plane? Oh, it's on this xc plane, huh? So if I mean, you want to distort it a little bit, you can. You can be like, all right, here it is. It's like right here. It hits this and it's coming back up, right? It's going through this value 2 on the z-axis, right? In the xc plane, true? But I only drew 1 trace. I only drew 1 trace. We're saying y can be what? Anything. So can you ride down the road here since y can be anything? Come on down here, let's just draw a similar trace. How about right here? I'm going to try to like duplicate that. You go, hey, just be careful. I'm just trying to duplicate what I did in my notes right there on the green board. I'm like, okay, this came down here, and it came back up like that, right? And because y is anything, now draw lines that connect these. All right, here we go. And watch how my lines are parallel to which axis? The y-axis. Here, I can improve it now, right? Hey, what's this look like? Any descriptions? Anybody ride a skateboard or something like that? This looks like one of those skateboard ramps, right? Like the half-pipe stuff, the Winter Olympics. If you want to shade it in to make it look better, they call these rulings. If you want to make it look better, these rulings are always parallel to that letter that was missing. And there's the rulings. It's like a half pipe. Cool. What kind of cylinder is this then? It's not a circular cylinder. It was like a parabola, so the adjective will be parabolic cylinder. Can you try one more of these? How about z? No. Yeah. How about z equals 1 minus y squared? You'll get stuff like that in our course. First of all, how do I know that's a cylinder? 2 variables. Who's missing?
X.
X is missing. X can be
Anything.
anything. X can take on anything. We'll try to make a rough sketch. Ah, there's a 1 in front. It's shifted up 1. What did the minus do? Right? I'll do this in the z and y plane, and here's z, here's y. I'm going to go up here and just kind of what? Yeah. So far so good? This is the x-axis. Where can I make another trace? Somewhere down the x-axis, right? Because x takes on anything. Here, just make another trace. Here, you can always improve it, see? You just want to make sure that they're running parallel to the what? That x-axis. Again, you can always put extra rulings in there if it helps. Shade it in. Just give it a little shade. There it is. Now it looks like a tunnel. True? There you go. So when you drive out tonight, you're going to be looking at shapes on the side of the roads going, it's kind of like the parabolic cylinder we did. No? Okay, great job with that. Well then what's this? X squared plus y squared equals 9, everyone,
This is circle.
in 3 space. So I want to make sure we're not just talking about 2 space, because in 2 space it's a circle.
Circle, yeah.
What's this?
Oh, sphere then.
And the key is, it's only got 2 variables.
Yeah.
So you know it's a cylinder. But this time it's not parabolic. What kind of cylinder is this? It's a circular cylinder, you bet. Because you're in 3 space, and which variable is missing?
Z.
So that circle will be centered on which axis? The variable it's missing. That circular cylinder will be centered on the axis that is missing. Okay. What's the radius? I do want to point out, everyone, when I'm talking about this cylinder, you're like, is it all the points inside of it? No. It's only the points, when I'm doing this, only points on the surface of the cylinder is what I'm describing here. Okay? And I'll just run that down like that. This keeps going though, doesn't it? And if you want to go even further, this would be an infinitely long circular cylinder centered on the z-axis with a radius of what? 3. And it just keeps going. There's another trace. You can put traces all over the place. Keep putting traces. But the radius is 3, right? Centered on the z-axis because which letter was missing?
Z.
Right? So, you know, how about this guy? X squared plus z squared equals 4. Which axis is it on?
Y.
And it's a circular cylinder, right? You can just draw that y-axis and be like, here, here, there it goes. X, Z, there's X. But it's only the points on the what? That lateral surface. How do you describe points inside it? You just got to do a less than or equal to. Now you got all the points on the surface and inside. Cool. Great. So we did parabolic cylinders. We did circular cylinders. And, oh, one more. On my sheet here, I wrote this. Can you help me out with this? I wrote y squared plus 4z squared equals 4. That's got to be a cylinder. That's got to be a cylinder. It's only got 2 variables, right?
Mm-hmm.
But daggone it, it's not circular. But do you agree it's almost circular? So this stupid 4 being here, what did it really do to that nice, perfect circle? Stressed it. Like an oval, so they call this an elliptic cylinder. So it's going to look like this, right? Well, which letter's missing if you want to make a rough sketch?
X.
So this is what I do. Never freak out about this. You want to draw a rough sketch of this, so it's centered on the x-axis. I just use intercepts. You know what I mean? Like, pretend y is 0. And pretend x is 0. So x and y is 0. We're saying x can take on anything. What would z be? 1. What else could it be?
0.
Plus or minus 1. Do you all agree?
Uh-huh.
Let me make sure. If I let x and y equals 0 in this
Oh,
relationship, z would have to be plus or minus what?
Uh-huh.
1. Well, let's pick another intercept. Right? Let z equal 0. Let x equal 0. What would y be? Well,
Plus or minus negative 2.
plus or minus 2. So now you can see, if you're curious, which way is it more stretched? I just use intercepts. I just check the intercepts. Which way is this funny looking elliptical cylinder? It's an elliptical cylinder. Which way is it more stretched? It seems like it's more stretched along the what? The y-axis. Right, so now I'll go negative for y, right? This is the positive y. And for x, z, no. Yeah, plus or minus 2, the z went up what? 1, you can take this down 1. And here's one trace. Look at this. There's one trace that I got on my cylinder. One trace. But if you want to make another trace, which letter's missing?
X.
Go down the x-axis, duplicate that. Okay, here you go. Just duplicate it and then do what? Sometimes I have to improve it. I want to make this run nice and parallel. Just improve that trace. Or do you want to put some of these? They call these rulings. Make it look cool. You can. Elliptical cylinder. Elliptical cylinder. Hey, one more I want to show you before we do the quadratic surfaces. They go just as quick, but it's so important we can do these. Now when this is in 12.6, I wonder if you could come up with this. Ready? Number 7. This one kind of stands out from the others. But isn't that a cylinder? Can I erase this? F1 equals sine y. How many variables?
2.
That's a cylinder. It's just not nice and circular. It's not a parabolic cylinder. The common ones we'll see, but we can sketch this, can't we? Who's missing?
X.
All right, well, let's just see. Let's get this thing started. Can we just do one trace of a sine curve? There's the z-axis. There's the y-axis. What's the sine curve do? You know, it goes up, then it what? Makes it like a pi value around here, then it comes back down and what? And they keep doing this. Right? And they keep doing that along the what?
Y.
The y-axis. Now which variable is missing?
X.
Let's make another trace. Go down here and just do what? Just duplicate this trace. Here you go. Now what is this way to describe it? I mean, it's a cylinder, but what is it? It's like a wave, isn't it? My bad.